So part E says, based on the trends shown in the data, estimate the winning time for women in 2015. So estimating, we're going to use the linear regression equation. Okay. So we had our equation was our estimated winning time for women was negative 0.1713 times t plus 43.5355. And t was years since 1970. So we want to estimate the winning time. So we want a W, the winning time, and we want to estimate, so a little hat on there. And then for the year 2015, okay, so in 2015, this is 45 years since 1970. If we take this and subtract 1970, we get 45. So this is a t, a value of our variable t of 45. Okay, so we want the estimated winning time when the input variable is 45. So we're going to take W hat and we're going to plug in 45 for t. Okay, so in our calculator we can hit negative 0.1713 times 45 plus 43.5355. And if we do that, we get roughly about 35.83 seconds. So our guess, our best guess for the estimated winning time in the year 2015 for the women would be 35.83 seconds. Okay, well now in part F, we're asked to do the same thing now for the men data instead of the women's data. Okay. So again, we want to estimate the winning time. So winning time and estimated winning time, but now, oops, for men, so an M. And the year 2015, we've already determined up above, that corresponds to a t value of 45. So now we want the estimated winning time for men. And that equation from the previous page looked like this. So now, if we plug in for t, we're going to replace t with 45. So on the calculator, we'll type negative 0.1446 times 45 plus 39.8476. And if we do that, we get about 33.34 if we round off to 2 decimal places. So we predict, or we estimate, that the winning time for men in the year 2015 will be 33.34 seconds. So now part G asks us how you can tell by looking at the equations, that should say by looking at the equations that the lines must intersect. Okay. Well, for lines to intersect, they need to have different slopes. If the slopes are the same, then we either have parallel lines or coinciding lines. But for lines, if the slopes are different, the lines must intersect. And if we look at our two lines, okay, the slope, so we'll just use M1, slope 1 was negative 0.1713 in our first equation, coefficient on t, and the slope in the second equation was negative 0.1446. Okay, so we have different slopes, so the lines must intersect. So since these slopes are different, these lines must intersect. And we said it's extremely important to be looking at those numbers and knowing that that is true. Sometimes the slopes can be very close to each other, and on the tiny view screen of our calculator, it may actually look like the lines are parallel when they're really not. One of the lines' slope is just slightly different than the other one, which we can see in the numeric values. So now part H, we're asked to solve the system from part D using the substitution method. Okay. So if we take a look at these two equations that we started with, we could, and if we write them in terms of x's and y's if we prefer, we would have y equals negative 0.1713x plus 43.5355, and y equals negative 0.1446x plus 39.8476. Okay. So here's our system that they've asked us to solve. And solve a system means to find all the ordered pairs, in this case, since our system has two variables, x's and y's. So we want to find all the ordered pairs that make both of these equations true. Okay. Well, if there is such an ordered pair that makes them true, then this y is the same as this y. And so using the substitution method, we're going to take this first equation's already been solved for y, and we can substitute that for y in the second equation. Okay, so we would get negative 0.1713x plus 43.5355 equals negative 0.1446x plus 39.8476. Okay, so we've just substituted this expression in for y in the second equation. All right, so now we have one equation and one unknown. Okay, so we want to solve for x. Okay, but we've got an x term on each side of our equation. So we've got an x term and a constant term, so nothing can be simplified on the left side. The right side we have an x term and a constant term, so nothing can be simplified here as well. Okay, so to solve for x, we want to bring these two terms together on the same side of the equation. So I'm going to add 0.1713x to both sides. And to kind of cut down on some length of steps here, I'm going to bring my x term here, and which means I'm going to bring my constant term to the other side. So on the same step, I'm also going to subtract 39.8476 from both sides. Okay. So here we've got a negative and a positive. This will give us 0 times x, so this variable is eliminated on the side. And so if we take 43 minus this 39, we get 3.6879. Here we've got a negative 0.1447, I'm sorry, negative 0.1446 plus 0.1713 gives us a positive 0.0267x. And here we're adding 39 and subtracting 39, so this gives us plus 0. Okay. So now we're still trying to solve for x. It's being multiplied by this number. So we're going to divide both sides by 0.0267. And we'll get x equals 138.12. Okay, but now if we go up and see what we were asked to do, solving the system, we're asked to find an ordered pair. Okay, we're not quite done. We only have an x. And to get y, we can plug it in either equation because, again, it's going to be the point where these two lines intersect. So no matter which equation we plug it into, we should get the same y value. Okay, so if we plug in that y coordinate, we get negative 0.1713. I'm plugging in that x coordinate to solve for y. Negative 0.1713 times 138.12 plus 43.5355. Okay. So that comes out to be about 19.79. So if we put those together as an ordered pair, we've got about 138.12 and about 19.79. Well, our other alternative is when we did our stat arrow 4 and then did L1 comma L2, we could have stored that equation in y1. Okay, and to type this, we use variables over 1, 1. And for the male data, we could have done the same thing, stat right arrow 4 for linear regression, and then typed L1 comma L3, and then typed a Y2 to store that equation. Variables over 1 and 2 to type a Y2. Okay, this will store both of the equations for us so that we can then see their graphs. Okay, so on this one, we're going to set x-min to be 0, years since 1970, and then we can just start with some x-max to see if it's big enough. If not, okay, so we'll just try this. Okay, if it doesn't work, we'll come back and make it bigger. Okay, but then we're going to push zoom 0, and that will make the calculator automatically adjust the y-min and y-max to capture the graphs. Okay, so then on screen, you should see one line that kind of looks like this, and another one that kind of looks like that. Okay, pretend those lines look straight. And so if we use the intersection feature now on the calculator, okay, we are going to push second and trace, because that says calc above it. And we're going to push button 5 for the intersect feature. Okay. And then we can push enter, enter, enter to get by the 3 questions. And at the bottom of the screen then, we should see that this point is about 139 and 19.79. So if we explain in the context what the solution to this system represents, okay, so if these trends continue, sometimes trends do and sometimes they don't, okay, so, but if these trends continue, okay, about 139, so remember the input here was years since 1970, okay, about 139 years after 1970, men and women will have the same winning time of 19.79 seconds. Or we could say we estimate that. Okay. So again, we've got our 2 equations. They both had negative slopes, slightly different slopes, so eventually they did need to intersect. So again, our x-axis here runs from 0 to 160. Remember, you do need to be able to see that intersection spot in the view screen before you can hit second trace 5. So here, had we tried 100, we wouldn't have quite seen it yet, and we would have had to make x-max a little bit bigger. Okay, so here, that's why I said we just tried it. We pushed zoom 0, we could see the intersection. If not, we'd make x-max a little bigger. We'd hit zoom 0 until we saw that intersection point. And again, we can get to these by pushing window to type in that x-min and x-max.